Okay, so these notes are going to be on sequences. So there are two types of sequence. The first is going to be an arithmetic sequence. So an arithmetic sequence is a series of terms where the same number is added over and over again to get the next term. So we call that a common difference. So that is a little confusing that it says that we're adding, but then we call it a common difference. So just know it could be actually adding, and the sequence would be increasing in values. Or it can be adding a negative, which is essentially the same thing as subtracting, and so the sequence values would be getting smaller. Either way, we still call this a common difference. So is the difference a positive number or is the difference a negative number? So you'll see this in these formulas here that is denoted by D. The common difference is D, okay, in both of these in arithmetic sequences right here. Okay. All right, a geometric sequence is a series of terms where each term is multiplied by the same number over and over again to get the next term. So a geometric sequence, also like an arithmetic sequence, can either get bigger, like the numbers could be increasing or decreasing. Either way, we're still multiplying. So if you multiply by numbers larger than 1, obviously the sequence is going to be getting bigger. If you're multiplying by numbers that are like fractions, so between 0 and 1, then the numbers would be decreasing. Know that you can also multiply by a negative, and so those sequences are a little bit different because they alternate from a negative number to a positive number back to a negative number. So we'll see one like that here in just a minute. Okay, so we're going to write sequences, which you've done for a long time in elementary school. Even in middle school you did sequences, but what's big and different about sequences in Algebra 1 is that we use a formula to write it. And so I agree that is confusing for a lot of people, but I'm going to try and make it as simple as possible. So the word recursive is how we describe these formulas. So recursive just means we rely on the previous term. So means to like repeat. So go back and use the previous term to find each term. At least one term must be given. Hopefully the first one, but sometimes that's not the case. They may give you one right in the middle of the sequence, and then you have to both work forward and backwards. But one term has to be given for you to know how to use that number to generate the sequence. So we have function notation, and I'm not sure that subset is the correct word, but I like the word sub just because it has the little numbers that are subscript. So I'm going to call it subset notation. I have no idea if that's correct, but we're going to call it that. So function formula is where we use f of x. So function notation. So f of x means the term we're looking for equals the previous term. So f of x minus 1. So to get to the previous term, I would have to go back 1. So that's why we would subtract 1 plus the common difference. Can also be written like this. So this f of x plus 1 would be the next term is equal to the current term plus the common difference. Okay, so that is arithmetic. Again, we're adding a common difference. It could be a negative, so in that case you might actually see a subtract sign there. But either way, you're using the previous term here and adding the common difference, or this one, to get the next term, use the previous term and add the common difference, which is exactly what these mean also. So this a sub n minus 1 means take the previous term and add the common difference to get the next term. This means the next term, the term plus 1, is equal to the current term plus a common difference. So I know that is confusing, but we'll look at here in just a second, and I think I can clear it up. Geometric sequences are the exact same, except instead of adding a common difference, which again could be subtracting, we're multiplying by a common ratio. So again, that common ratio can be a whole number greater than 1, so the sequence would be getting larger. It can be a fraction between 0 and 1. In that case, it would be getting smaller. It can also be a negative number of any kind, so in that case, it would be going back and forth from negative to positive. So f of x minus 1 means the previous term. F of x plus 1 means the next term. F of x is the current term, and r is the common ratio. Same thing here. A sub n minus 1 is the previous term. A sub n minus plus 1 is the next term. these two, a sub n, are just the current term, and r is the common ratio. Okay. Again, for each of these, one term must be given. Just know the first term can either be f of 1 or f of 0 in function notation, or in sub notation or subset notation, it could be a of 1, a sub 1, or a sub 0. So there's no real rule on do they have to give you 1 as the first term or 0 as the first term. So really important that you know that, okay? All right, so the first thing we're going to do is we're going to identify each of these sequences as arithmetic or geometric, and we're going to explain that, and then we're also going to take it, once we know what kind of sequences, we're going to put it on the next page. So on the next page we have an arithmetic section at the top and a geometric section at the bottom. So we're going to list those sequences where it says sequence in the correct place, because then we're going to use it to write some function rules. Okay. All right, so identify each one as arithmetic or geometric and explain why. So if you look at the first one, we have 0, 1, 2, 3, 4. So what you should notice is that this sequence is just adding 1 each time, right? 0 plus 1 would be 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4, and so on. So our sequence here is just adding 1 over and over again. So I'm going to zoom way in so I can write this. So right here, we're just adding 1, maybe. Adding 1. So this is plus 1. This would be plus 1. Over and over again. So we're adding 1. So this would be an arithmetic sequence. I'm going to write that arithmetic. That's an A. Arithmetic sequence. And because it's arithmetic, because the common difference, so right there, that's a common difference because we were adding, or in this case we were adding. So the common difference is plus 1. So I'm going to zoom back here. So because the common difference is plus 1. Plus 1. So we're adding 1 over and over again. Okay, so what I'm going to do is I'm going to take that sequence 0, 1, 2, 3, 4, and I'm going to put it in the arithmetic section on the next page. So 0, 1, 2, 3, 4 is going to be my first arithmetic sequence. So over here, I'm going to write that in this spot, 0, 1, 2, 3, 4. Okay. All right, and then I'm going to go back, and we'll come back to that here in just a minute. Okay, the next one we have -8, -2, 4, and 10. So some students might struggle from -8 to -2, not really sure what happened there. Maybe even the same from -2 to 4. So what you definitely might know from 4 to 10 is that is adding 6, right? So 4 plus 6 would be 10. So then I would just check that. Is -2 plus 6 4? And is -8 plus 6 -2? And in this case, that is correct. So -8 plus 6, -2. -2 plus 6, 4. 4 plus 6 is 10. So this is also going to be an arithmetic sequence because when we're adding 4, or not 4, sorry, adding 6 over again, so from there to there is plus 6, there to there is plus 6. So arithmetic is when we add or subtract. In this case, we're adding. So this would be an arithmetic sequence. Because the common difference, again, so this is going to be difference. So the common difference is plus 6. So I'm going to add that in over here. So common difference is plus 6 because we're adding, it's arithmetic. All right, so I'm going to take that sequence, -8, -2, 4, and 10. I'm going to add it to the arithmetic section again, just like last one. So -8, -2, 4, and 10. So -8, -2, 4, and 10 is that sequence. All right, so let's go back. Let's check this one. Next one we have -5, then +10, then -20, then +40. So one really obviously important, obvious difference is that this one goes from a negative to a positive, back to a negative, back to a positive. So what you should notice is that you are multiplying, hopefully, by 2. But in this case, it's not just a 2, it's a negative 2. So a negative 5 times a negative 2 would give you a positive 10, because a negative times a negative would be a positive. Then a positive 10 times that same negative 2 would be negative 20, and negative 20 times negative 2 would give you positive 40. So this is the one I was talking about where it goes back and forth from a negative to positive to negative to positive. So this one, because we are multiplying, so from negative 5 to 10, that is times negative 2, or 10 to negative 20 would be times negative 2. So because we're multiplying by a negative, this one is called a geometric sequence, because we're multiplying. So it is a geometric sequence because the common ratio, so when we are multiplying, it's no longer called a difference, it's called a ratio. A ratio is what we're multiplying by. So its common ratio is negative 2. So negative 2. You might even, some people might want to write in times negative 2. So we're multiplying. I'm going to use a dot for times, not an X. So times negative 2. So I'm going to take this sequence, negative 5, 10, negative 20, and 40, and add it to the geometric section on the other page. So negative 5, 10, negative 20, and 40 is going to go in the geometric section. So that's arithmetic. So we're going to go to geometric. So negative 5, comma, 10, comma, negative 20, comma, 40. All right. Next one, we have 8, 6.4 or 6 4/10, and then 5.12 or 5 1200. So this one is definitely a little bit more difficult because we go from a whole number to a fraction or decimal number to a smaller fraction or decimal number. So some people might be able to make an observation here that if I multiply 8 by 8, I would get 64. Well, I don't have 64, I have 6.4. So if you think about where does that decimal need to go, you could multiply 8 by 0.8. So 8 by 0.8, or 8 times 8/10 would be 6.4. And then if you think about 6.4 or 64 times 8 would be 512. So 6.4 times 0.8 again would be 5.12. So if you're not sure on that, I'll show you on my calculator that 8 times 0.8 or 8/10, so 8 times 8/10 is 6.4, and then 6.4 times 0.8 again would be 5.12. I could do it again to get the next number in the sequence, which would be important that you could do that. You would get 4.096. So if you're not able to make that observation, another way you could do it is if you can't figure out what to add and you think that you're definitely multiplying by a ratio here, you could divide these and just work your way backwards. So if you did 6.4 divided by 8, so if I do that, 6.4 divided by 8, you get 0.8. So that tells you what you had to multiply by to get the 6.4. And then same thing if you did 5.12 divided by 6.4, that would also tell you 0.8. So that tells you that your common ratio would be 0.8. Okay. All right, so I'm going to get my paper back here. So my common ratio, again, I'm multiplying. So my common ratio is 0.8. So this is going to be a geometric sequence. So it's geometric, again, because we're multiplying. My common ratio, I'm going to write that here in just a second, is times 0.8. So times 0.8. You could definitely write that as a fraction if you would like. If you would want to change 0.8 to a fraction, you can do that. It's totally up to you. That would be 8/10, which would simplify to 4/5. So just know you might see it as 4/5. but we'll just leave it as 8/10 for now. All right, and then I'm going to scroll over here because the common ratio, again, when we multiply, it is a common ratio. Okay, or geometric sequences, it's a common ratio. All right, so I'm going to take that sequence, 8, 6.4, and 5.12. I'm going to put it in the geometric section on the other side. So geometric, we're going to write it in here. 8, comma, 6.4, comma, 5.12. All right. Okay, I'm gonna stop with the last two. I'm gonna let you figure those out. I want to go to the next page and talk about how we would fill the rest of this in here. So we have an arithmetic sequence, 0, 1, 2, 3, 4. We already decided that. We are also already decided that our common difference was +1. We are adding 1 over and over again. So I just added that in there. Our common difference is +1. All right, so the second line, f of 1 or a sub 1, those are basically asking for the first term in the sequence. They just want to know, what is the first term in the sequence? So the first term in the sequence is given to us. Our sequence was given to us, so this isn't really difficult for you to figure out. I just want you to see the notation. So this number right here, my bad, this number right here is the first term in the sequence. It could be f of 1, so they could describe it as this as f of 1, or either one, a sub 1. Either one of those is the same thing. It just depends on if it's in function notation or that subset notation. So f of 1 is 0. Same thing on the other one. A sub 1, again sub because it's below, is also 0. Those are the same thing. It's asking the same question. I just wanted you to see that it could show up as f of 1 or a sub 1. Okay. Here we're going to put it in the different the equations in different terms. So we're going to write this first one in function notation. And again, there are two ways, but I'm just going to do one of them. And hopefully you understand enough to be able to get it. So we're going to write in function notation that f of x, so function notation is f of x, is equal to the previous term. So to get the previous term, we would do f of x minus 1, right? Because to go from 1 to 2, I had to know that 1 was there. To go from 2 to 3, I had to use the 2. So I take the previous term and I add 1. The +1 comes from my common difference. So this part right here is just how we write it. The only part that's really important that you need to figure out is this +1 right here, and that +1 came from right here where we had that our common difference was +1. So in subset notation, or in that a sub n notation, it's very similar. So we're going to write a sub n. So that means any term, the nth term, is equal to the previous term. So to write the previous term, we would say a sub n minus 1 plus 1. So I take the previous term and I add 1. Again, this part right here is just the notation. All that's really the part that you have to figure out is this right here, this +1. Okay. All right, so let's look at the next one. Same situation. We had -8, -2, 4, and 10. And we already said that the common difference there, we are adding 6 every time. So our common difference is going to be +6. So my common difference here is +6. All right, so f of 1 or a sub 1, again, that just means the first term in the sequence. So the first term in our sequence, hopefully you know, is the first number that they gave us right here, this -8. That's the first term in the sequence. So -8 is the first term in the sequence. Okay? So I'm going to write f of 1 is -8, a sub 1 also -8, same number. All right, in function notation, we're going to write it as f of x. So any term or the next term is equal to the previous term, which is f of x minus 1. And then our common difference, again, go back over here, our common difference is what we have to put at the end. So our common difference is +6. So +6. Again, The only part you have to really know is this plus 6. This part right here all is just the notation. That's what makes it difficult, but that's all it's going to look like that almost every time. Okay? So subset notation, very similar, is just a sub n, that means any term or the nth term, is equal to the previous term, a sub n minus 1, so the previous term, plus 6 is our common difference. So this is just the notation. This is the part you have to know, and we get that from right here, this plus 6. Okay, so let's look at the geometric ones. Very similar. So the first one, our sequence was -5, 10, -20, and then +40. So maybe you remember that our common ratio, again ratio because it's geometric, we're multiplying, was times -2. Right? You're multiplying every one of these by -2. So f of 1, again, or a sub 1 is the first number in the sequence. So f of 1 in this case would be -5. A sub 1, same thing, -5. So in function notation, it's f of x, so any x term, or the next x term, is equal to f of x minus 1. That's the previous term, so we would subtract 1 to go backwards 1. Then times -2. So I do want to talk about that for just a second. So typically when we're adding or subtracting, we would put that at the end. When we're multiplying, we generally put that at the front. I don't care either way. I do really want you to understand that we do have to put that multiply. So this, a more common way to see this would be like this. It would say f of x, same thing, equals, because we're going to multiply this -2 times that, we would generally put it in the front. So we're going to put -2 and then just f of x minus 1, because when we just attach them right there, that means to multiply. So if you put it at the end, you have to put the times sign. If you put it in the front, it just automatically implies multiply because they're just attached. So that second one is definitely going to be the way that we're probably going to want to write it. So I'm going to kind of highlight this. It's probably not going to show up very well on this screen, but this second way is what we're going to see probably on any kind of test question or practice problems. Okay. All right, so the subset notation, the a sub n part, very similar. We would just write a sub n, so that means any term or the nth term, is equal to, again, I would put the -2 in the front because I'm multiplying. So just one tiny difference between that and arithmetic. So -2 and then a sub n minus 1. So I would do -2, and when you just attach those right there, when these are just put together like that, that automatically means I would take -2 and multiply it times whatever that previous term was. So I'm going to just point how this works right here. So if I have the first term, I'm given the first term, -5. To get the second term, 10, I already know it, but to get that, I would take -2 and I would multiply it times the previous term. So the previous term to the second would be the first term. So I would take -5 and plug it in right there. This whole thing would be -5. So -2 times -5 would be +10, which is my second term. So then to find the third term, I'll write this how another way you might see it would be a sub 3. So the third term is equal to -2 times a sub, n was 3 right here, so n is still 3 right here, 3 minus 1. Well, 3 minus 1 is just 2. So a sub 3 is equal to -2 times a sub 2. A sub 2 means the second term. So our second term was 10 right there. So I would do -2 times 10, and -2 times 10 is -20. I ran off my page here. -20, so a sub 3 is -20. And if you go to our sequence, a sub 3, the third term in the sequence, is -20. So again, I know that this looks very complicated, but I think if you understand, n just means the next term, n minus 1 means the previous term, same thing, x means the next term, x minus 1 means the previous term, it makes a lot more sense. Okay. All right, let's look at one more. So it says 8, 6.4, 5.12. So again, our common ratio on that one was a little bit different. The numbers were getting smaller, so we were multiplying by 0.8. Again, you could change that to a fraction, so that's 4/5. If you would rather have it as a fraction, those are the same thing, doesn't really matter. Okay. All right, so f of 1 is just our first term in the sequence. So our first term in this sequence is 8. A sub 1 over here, also just the first term in the sequence, so that's also going to be 8. I did that just so you could see, like, this f of 1 right here and a sub 1, those mean the same thing. Okay? Function notation. So function notation just means f of x is equal to f of x minus 1, that means the previous term, times 0.8. Again, though, that 0.8, we're probably going to put it at the front. So you're more likely to see it as f of x equals 0.8 f of x minus 1. So that just right there, because they're put together like that, they're just smashed together, that means to multiply. So I'm going to show you on this one, very similar to how I did up here. So let's say I want to find the second term. So I want to find f of 2. So I'm going to write f of 2 is equal to 0.8 times f of x is 2, 2 minus 1, right? X right here was 2, so x right here is 2. So f of 2 is equal to 0.8 times f of 2 minus 1. Well, f of 2 minus 1 is just f of 1. 2 minus 1 is 1. So that would be 0.8 f of 1. Okay? Then we know f of 1 is 8. Right here, we just said f of 1 was 8. So we would take 0.8 and we would multiply it times 8. And 0.8 times 8 is 6.4, which is f of 2 and also the second number in our sequence. So that's how that works. Okay, again, very complicated way for writing something pretty easy. All right, so let's write the subset notation, and then I'm going to let you practice. So subset notation, again, would just be a sub n, so any term or the next term is equal to the previous term, a sub n minus 1, times 0.8. Again, that 0.8, we're probably going to see it in the front right there. So, again, another way, a sub n equals 0.8, then just a sub n minus 1, because when those are just smashed together like that, that means to multiply. All right, so I'm going to stop there. If you are watching on your own, please try the rest, see how you do. If you're in class, we're going to do some together. I'll give you some more instruction on that. So.